So this question is a quadratic modelling question. And the first part of the question, it tells you that there's this volleyball tournament or volleyball serve. We can see that the net here is in the middle of the court and the ball is being volleyed over the net to the other side. And we have these 3 different points where we're kind of tracking the ball over time. So we're told that the height is modelled against the distance. So this is your X and Y axis essentially. And we need to find out what is the equation of this curve or parabola or quadratic that we're expecting to see. So the first part is to use the coordinates to find the equations. So we're setting up those simultaneous equations. And then the second part is then finding that function. So in terms of the quadratic equation, we know that any quadratic, this one is h of x, should follow the general format of ax squared plus bx plus c. So we're going to use that same idea, but this time we're going to substitute in each of our coordinates. So the first coordinate, we're told that the y value is 2.8 when the x value is 1. So that means that we've got 1a, because 1 squared is 1, 1b plus c. And then we have the next coordinate, and here the y value, is 2.86, so it's gone slightly higher, and the x coordinate is 2. So we now have a lots of 2 squared, so a lots of 2 squared, plus b lots of 2 plus c. And I'm going to rewrite that one as 2.86 equals 4a plus 2b plus c. And then I have my next coordinate, which is 2.89. And this happens when x is 3. So this is going to give me 3 squared, so 9a plus b, 3, so 3b plus c. So now I have these 3 different equations that have been set up. So I have my first equation, my second equation, and my third equation. So that's the answer to part A. And now I'm going to use my GDC to find the answer to those, but using my quadratic formulas. So I'm going to go into math, and so I'm going to go into apps, and I'm going to go into Polysimult 2 and simultaneous equation solver. Okay, so with my quadratic, I have 3 unknowns, A, B, C, so 3 unknowns and 3 equations, and I'm going to type all this information in. So the first one is 1, 1, and 1, and it equals to 2.8. Now it's a little bit confusing because this says X, Y, Z, and we have A, B, C. But all you're doing is writing the coefficients down, 1, 1, 1, 4, 2, 1, and 9, 3, 1, and making them equal to this number at the end. So you can see I've typed all of this in. And then we're going to find the answers to those. So I can see that A is equal to, so this is part B. This was part A. So A is equal to negative 3 over 200. B is equal to 21 over 200. And C is equal to 271 over 100. So obviously, yes, these numbers don't look nice, but I would leave them in fraction form and don't be put off if they don't feel like a nice number that would be an answer. And we can now write down our final equation. So h of x is equal to ax squared, so minus 3 over 200, x squared, plus bx, so 21 over 200, x, plus c, so 271 over 100. And that is the equation of my quadratic, the equation of the ball, that is modelling this volleyball, the equation of the model for the volleyball. And then part C says comment on what the value of C means in context. So C is my y-intercept. Okay, so C is my y-intercept, and my model is matching the height of the ball against the distance of the ball. Where the model starts at the 0, that is the point where, what's her name, Emily, is standing. So it's just at the height that the ball was hit. So height that the ball was hit, and that's what the C value means in context. So height that the ball was hit. And then part D is asking us that the net is, so for the serve to be in play, the ball must pass over the net, which is 9 meters from Emily. So this is 9 meters. And we know that she hits the ball 2.24 in height, and we need to work out, does it go over the net, okay, and does it land before the end, which is the 18 meters horizontally. So it needs to land back on the court before 18. So when we do this, we need to first of all graph it on our calculator, and then we're going to be using our TI Inspire to do most of this work. So if we come out of this, we're going to graph this function. So we have -3 over 200 x squared. And then we have plus, and another fraction, 21 over 200 x, and then plus, and the last fraction is 271 over 100. So we can graph this function, graph this graph, and I'm going to change this to be -1 because we're only really interested in 0, and we know that it's got to go to at least 18. So I'm going to say 20 for now. And let's see what this graph looks like. There we go. So we can see this is where they hit the ball. It goes over. There's a net somewhere here at 9, and then we need to see where it lands as well. So when we look at this, we could find, first of all, does it land in the space? So if we look for the 0, we can find where does our function land. And we can see there that it lands at 17.4 to 3 significant figures. So in terms of I'm going to draw this graph here for us to see, in terms of the marking and how you could show this, drawing the graph would be enough for you to see. So here is Emily, and she's hitting the ball that then kind of goes over like this. Now it lands at 17.4. That's where the ball lands down here. Therefore, it does go into play, so that's fine. And we could write that coordinate, so 17.4, 0. And then we also need to see if it crosses over the net. So here we're going to be looking for the value of 9, because the net was 9 meters away. And it crosses at 61 over 25. So if I come out of that, I can work out what is that fraction, 61 over 25, and it's 2.44. So it crosses the net at 9 meters, and that's the coordinate of 2.44. Now, we were told that the net height is 9.24. So yes, it does cross over the net. Our net was 9, 2.24, and our ball goes at 9, 2.44. So by 20 centimeters, it does clear the net. Okay, by showing that graph, that is then enough to show your working out. So if we go back to the question, in terms of the marks for this question, the first one is 2 marks. So you get both marks if you have all 3 equations correctly written, and you get 1 mark if you have 2 equations correctly written. And then for the second part there, for part B, you had to find the equation. So 1 mark is a method mark for correctly having the answers there. And then the second mark is for having exact or the correct rounding. So exact values or the correct rounding to 3 significant figures. Okay, so you need to have that on there as well. And then 1 mark is for the reasoning of where the ball was hit. And then the last one there is 5 marks. So we need to make sure we've shown our working really well there for those 5 marks. As long as you have something written in terms of where it lands on the court, we also need to have a comparison for the height that it goes over the net. You should have some sort of graph drawn in general showing this information, or if not, a paragraph really explaining it well. And therefore, you need to have for the final mark an answer mark, which is stating, which I hadn't done, that therefore the ball was in play. Okay, so you need to state that final answer at the end, that the ball was in play.